Hey guys, today I'm going to talk to you about properties. Properties, one definition is a piece of land, something you own like your bike. But in math, a mathematical property is a rule. It's a rule that is always followed when working in a mathematical situation. So I'm going to show you several properties and I want you to write them down, write a definition, and try to write at least one example for each of the properties. Let's start with something you already know. You know that when you add 0 to 6, you get 6. When you add 0 to 22, you get 22. When you add 415 to 0, you get 415. In other words, anything plus 0 is that same number. You knew that? Now here's the name of that property. That is the identity property of addition. Write that down if you didn't already know that. It says that any number added to 0 will stay the same. Here's an algebraic example. You can copy one of these or one of these examples in your notes. Any number added to 0 will stay the same. I'm going to flip through these pages pretty quickly, so feel free to pause the video to make sure you get those definitions and examples down. Okay, let's move along to the commutative property. Commutative property. One easy way to remember the commutative property is remembering the word commute. Commute means to move around, to move from place to place. Like your parents probably commute to work. That means they drive back and forth, or they ride the train or the bus. Commuting means moving around. What does this have to do with math? It's an easy way to remember the property. The commutative property says that a number can move around in a problem and the answer stays the same. Let's see how this works. Do these make the same answer? Let's take a look. 4 plus 5 is 9, and 5 plus 4 is 9. So when we move the numbers around with the addition, we still get the same answer. 16 plus 32 is 48. 32 plus 16 is also 48. You already know these rules. Now you're putting a rule, a mathematical property name to it. The commutative property of addition says that any added numbers can change places and the sum will stay the same. So the commutative property says that you can move numbers around when adding and the answer is the same. So when you see numbers moving around and you're getting the same answer, that's the commutative property. Let's see if this rule works for any other operations. Let's take a look. Does it work for division? 32 divided by 8 is 4. 8 divided by 32 is not 4. Let's check it out. 8 divided by 32, think of it as a fraction, that reduced is 1/4. Or if you were to divide 8 by 32, or 1 divided by 4, you would get 0.25. Not the same thing. 32 divided by 8 is not the same as 8 divided by 32. Therefore, the commutative property does not work for division, or division does not work for the commutative property. Let's check subtraction out. 14 minus 6 is 8. 6 minus 14 is not 8. It is negative 8. So, it does not work for division. It does not work for subtraction. Let's check multiplication out. 7 times 3 is your favorite number, 21. And 3 times 7 is 21 as well. So it does work for multiplication. So you can add that to your notes. The commutative property of multiplication says that any multiplied numbers can change places in a problem and the product will stay the same. I'll give you an algebraic example for your notes. A times B is the same thing as B times A. You can write that number example if you want. So far we've got the identity property of addition. Adding 0 to a number stays the same, the number stays the same. You've got the commutative property of addition and the commutative property of multiplication. Do you have those three so far? The definition and an example? If so, keep going. Let's look at the associative property. This is our fourth property for today. The associative property has to do with grouping. You can kind of think of associate. Who do you associate with? Who do you group with? Now think, in algebra, what do we use to show grouping? Parentheses or brackets. So the associative property says, no matter which numbers are grouped together with the same operations, the answer will be the same. Let's see how this works. Here you see an example. We've got 3 plus 8 in parentheses plus 10. Over here we've got 8 plus 10 in parentheses plus 3. Let's see what happens when we operate using order of operations correctly. So we have to do the parentheses first. 3 plus 8 is 11. And 11 plus 10 is, your favorite number again, 21. And in this example, we have to do 8 plus 10 first. 8 plus 10 is 18. And then we have to add on the 3. And we do get the same number. Go ahead, say it. You know you're trying to sing that song right now. 21. So, the associative property says that as long as all the numbers are added together, the grouping symbols can be rearranged and the sum will stay the same. I'm going to say another way to say that is the associative property says that when adding numbers, you can move the grouping symbols or the parentheses and still get the same answer. Okay, you can rewind me and I'll say it again. Grouping numbers, the grouping symbols can move when adding and the sum stays the same. What do you think? Do you think that's going to work for any other operations? Let's check it out. Multiplication. Here you got the same exact numbers, okay? A lot of people think commutative property is the same as the associative, but it's not. In this one, you've got 5, 4, 2. This one, you still have 5, 4, 2. The numbers are not moving. What's moving? The parentheses. Here they're around 4 and 2. Here they're around 5 and 4. Let's check it out. Here, 4 times 2 is 8, and 8 times 5 is 40. In this example, we get 40. Take a look at this one. 5 times 4 is 20, and 20 times 2 is also 40. So, the associative property also works for multiplication. It says that when multiplying, you can move the grouping symbols, and you'll still get the same answer. You can read that, write it down, write an example. I'll give you 2 algebraic examples. So A plus B plus C is going to equal A plus B plus C, whether we do A plus B first or whether we do B plus C first. And we could do the same thing for multiplication. I'm going to use a dot to show the multiplication. And I'm going to get the same product whether I do A plus B first or B plus C first. That's the associative property. Okay? Again, I know I'm going quickly, but you can write all these down and pause the video if you need more time. Now there's one here that we didn't talk about. And I'll talk about it as we get to it. What I want you to do is try to match up these examples with the name of the property. And there's one that we didn't talk about, but you can use the process of elimination to figure that out, and then we'll talk about it. So pause the video and try to match up the properties with the example. Unpause it when you're finished, and we'll check your work. All right, let's see if we can match these up, okay? I'm just going to draw a line to match these up. 5 plus 6 is 11. 6 plus 5 is 11. And that is the commutative property of addition. Now, when you do your homework, you can actually abbreviate like commutative property of addition, like that, okay? 5 times 7 times 2 is 70. 5 times 7 times 2 with the parentheses in a different spot is also 70. And that is the associative property of multiplication. Again, you could write associative property of multiplication when you do your homework. 17 times 1 equals 17. This is one that you probably had to use the process of elimination to figure out, since we didn't talk about the identity property of multiplication. The identity property of multiplication says that when you multiply, I'll write the definition right here, a number by 1, you get the same answer. Let me rephrase that. Any number multiplied by 1 gives you that same number. And again, you can use this as an example. 17 times 1 is 17. Anything times 1 is going to give you that same number. So that's the one we didn't talk about. Right, this one, 4 times 10 equals 40, 10 times 4 equals 40. Hopefully you realize that was the commutative property of addition. We can call that the commutative property, of multiplication. That's not addition, multiplication. All right, 2 more. We're almost finished. Hang in there. It's a lot of vocabulary here. Here we got 7 plus 2 plus 3 plus 4 equals 16. And the numbers are in the exact same position, but the parentheses are moving. Here they're around 7, 2, and 3. Here they're around the 3 and the 4. So remember, when the parentheses move, think grouping, association. So that's the associative property of addition. I think I erased the line here, so that would be the associative property of addition. We can call it associative property of addition. There you go. And one more, and it has to be the identity property of addition. You remember that? Says that any number added to 0 is that same number. Okay, so we can call this identity property of addition. There was one that we didn't talk about, or one that we didn't label. Yeah, here, the identity property of multiplication. Okay, how'd you do on that? This takes a little bit of practice, a lot of vocabulary here. Make sure you have the 6 properties. There's really 3 properties, and they all work for different operations, multiplication and addition. And make sure you have an example and a definition for each of those. We'll practice more with properties tomorrow, and I'll see you then.